Yo, what's up, guys? Welcome back. Episode, I think like 129 or something. Oh, actually, today's gonna be a little bit of a shorter video. Man, I'd be really been grinding pickleballs. I just spent like 3 hours playing it, and my whole body hurts. I feel like I make excuses every time about this pickleball stuff, but generally, I am so tired. I just woke up from a 2-hour nap, and my body is just like so sore. But yeah, so let's take a look. We got a Magikarp today, a OG Pokemon, maybe one of the most OG. Let's jump to this. Magikarp cup, Magikarp cup, Magikarp cup, Magikarp cup, Magikarp cup, Magikarp. Yeah. Gonna jump into a few problems. Let's let's jump into some problems. Sorry, man, a little out of it. Verify I'm a human, man. Alright. Maximize number of target nodes after connecting trees to. Hard problem. Huh. Let's maybe jump into some random problem today. Ow, ow, ow. So we can find along here. N queens. Spiral matrix 2, valid number. Populating next right pointers in each node. Okay. Populate each next pointer to point to its next right node. If there is no next right node, the pointer should be set to null. Initially, all pointers set to null. 1. Oh, next right is 3. So I think we still have everything. 1, 2, 3, 4, 5, 6, 7, right? But every single next pointer should be a hashtag. Okay, so this is obviously a BFS problem. Reason why the intuition, the reason why I know that it's a BFS problem is because after each level, the next right pointer, you might be thinking, I feel like a new person in this problem would be thinking, oh yeah, like let's just like do DFS or do whatever searching algorithm, and just point next right and add a hashtag with it. But that's not the way to do it. Like we got to loop through this using BFS, and then once we loop through the level, so we finish the level, then we add a hashtag. We finish the level, we add a hashtag, right? So at least, I don't know, I feel like that's definitely the way to do it. From collections, imports, DQ. Let's go through. So we got our res here. Let's initialize our queue. So Q is equal to DQ. We got to append q.append our root. I feel like that's all we need, right? So then we go while q. We do the length. So let's do n is equal to the length of q. We loop through, so for something in range n, okay, we'd want to pop, right? So we pop q dot pop left. So let's do node is equal to q dot pop left. Man, I have to go to the bathroom. Length n. Okay, so we pop the node. Then we want to check. Okay, well, actually, no, we're gonna need I here actually. So for I in range n. Okay. Then we want to check. Well, if I is equal to the length is equal to n minus 1, then we know we're at the last. We know we are at rightmost node. Okay. Then we can do we're at the rightmost node, so we can do res.append. We can append hashtag, right? Append our node, right? We do res.append node. Let's then return our res. See what we get here. Hashtag is not a valid value for the expected return type. What the hell is this then? Man, I'm blanking out, dude. What is null in Python, dude? I'm literally blanking out. None. Must be, you must have to append none. Dude, I don't know what is going on here. Okay, we have this. So for some reason they need, I must have just not understood the question properly. They do the same thing. Okay, they pop here, res.append. I literally totally forgot to add it back to the queue, so we need to do, okay, well, if node.left, res.append, node.left, if node.right, res.append, node.right. Okay. We pop the node. We check, okay, well, if prev.next is equal to node, prev is equal to node. Okay, so if prev is equal to node. If not node, if not root, turn root. Ah, shit. Sometimes you return none. That's why. Output expected. If prev.next is equal to node. I'm not really understanding what is going on here. Ah. Q.append. Q.append. I feel like I didn't really understand this question properly, but I don't really understand why we're doing this. That's the only thing I don't get. If prev.next is equal to node. I don't understand how this is changing. This is a hashtag. Like, I don't get that. Like, how is this changing it to hashtags? Where's the end of that level? Yeah, I'm a little confused here. I think this is just a terrible problem anyway, so I'm not even going to bother with it. I kind of want to finish this, man. Took out combination sum 3. Find all the valid combinations of k numbers that sum up to n such that the following conditions are true. Only numbers 1 through 9 are used. Each number is used at most once. Return a list of all possible valid combinations. The list must not contain the same combination twice, and the combinations may be returned in any order. What? Find all valid combinations of k numbers that sum up to n. Oh, okay. K numbers that sum up to n. Okay. So we can only have 3 numbers. Has to be 3 numbers. Okay. This is a good problem, I think. Def backtrack. Okay. You know, our base case is going to be, well, if I'm trying to think. I think we're going to need some sort of value, right? Oh, it looks like here we've got a list of a list. So let's use cur. Let's create our res array. Let's loop through. So if I is less than the length of cur. Alright, if the length of cur is equal to k. Shit, I'm trying to think here. the length of code is equal to k. We want to return. We want to do, okay, res.append code.copy, right? Now, once we get there, recursive case, right? Let's do, alright, well, if, what are we gonna have to do here? We're gonna have to either skip, so either we're gonna need to take, so we would do, we'll code.append 1, code.append n, right? Or skip, right? Where we do code.append n, and then we do, we'll backtrack cur n, and then we would do, well, we'd backtrack cur n plus 1, right? N plus 1. If n is less than or equal to if let's make this num. Take it to the max. Take it to the max. If num is less than or equal to n, then we can do this. Is that gonna generate all possible cases there? I don't know. I don't think so. Backtrack cur I'm just trying to get some shit in the array, dude. Let's do, okay, if the sum of cur is equal to k is greater than no, that's gonna be too expensive. We can't check if it's greater than k every single loop. The sum of cur is greater than n. We can return, right? And the sum cur is equal to k. And so otherwise we need to do like the only way I can think about doing this recursive case here is to have like an I here, right? That increments after each loop, right? And we can either take that I or we don't, right? So we can either do cur.append I and then we can backtrack, right? Backtrack I plus 1 cur num. I don't even think we need num anymore, to be honest. Right? Or we do cur.pop, then we backtrack I plus 1 cur num. And basically guess we could do, well, if I is greater than n, then we can return. No way that works, dude. One 17, 216, 315, 414. But it's expecting num. Each number is used at most once. Oh, okay. If I is this gonna work, dude? Oh wait, it worked. That's crazy, dude. What a problem. Okay. Leetcode 75. Multi-dimensional DP. Unique pass. Oh, man, we've already done it. Let's get rid of this. Is the one we haven't done? We haven't done this one. Let's take a look at this one. There's a robot on M times N grid. The robot, we've done this one recently, May 4th, yeah. Times N grid, the robot is initially located at the top left corner, i.e. grid 0, 0. The robot tries to move to the bottom right corner, grid N-1, N-1. Then the robot can move either down or right at any point in time. Given two integers, M and N, return the number of possible unique paths that the robot can take to reach the bottom right corner. Input M is equal to 3, N is equal to 7. Let's do rows is equal to the length of rows. Cols is equal to the length of cols. Let's print out rows. We can print out cols. Oh, whoops. Well, rows would be... Oh shit, I didn't realize that. I guess rows are technically M. And cols are technically 1, 2, 3, 4, 5, 6, 7. Trying to think here, what is the best way that we can do this? Obviously this is a 1DP problem, so it is a backtracking problem, but I'm trying to think, right? We can my initial thought here is to use BFS. Right? With BFS, you can either go here or here. Right? You can either go here or here. And every time you count that, that's a different path, right? So really, you can start here. You go here, that's 1. Right? 2, 3, 4, 5. Could be 28. We always append 0, 0, right? I'm thinking this is definitely a BFS problem. I mean, I did it like a month ago, and I honestly don't really remember, but I'm thinking this is probably a BFS problem. Let's import our DQ. And we go, well, for row in rows. No, we don't need to do that, actually. Probably need a directions array. Directions is equal to well, we can go right. To go right would be 0, positive 1, and then down would be, would be 1, 0, right? And then down would be 0, 1. This would be right, down. Okay. Thinking while queue, right? We need to obviously create our queue. So let's do q is equal to dq, right? Then we want to append to our queue, right? So we want to start at 0, 0, right? While queue, that's our row call is equal to q dot pop left, right? Then we can do, well, what do we want to do with that row call, right? We get the row call, then we want to for n row n col in directions. Alright, let's do new row is equal to n row plus row. New col is equal to n col plus col. Now we have to check if it's in bounds, right? So let's do, okay, so if 0 is less than or equal to new row, but is less than rows, and 0 is less than or equal to new col, but is less than cols. Now I think about it, we're going to need a visited array too. Visited is equal to set, and new row, new col, not in visited. Okay. Set, let's do visited dot add 0 0. Okay. Visited dot add new row, new col. I need to make these tuples. Got a tuple here, and okay, we visit dot add, we q dot append. Let's check. Well, if new row, new col is equal to grid row minus 1 col minus 1. Sorry, if grid new row new col is equal to row minus 1, or it should be rows and cols minus 1, then we know that we've got it, right? We've got something, right? So let's make a count variable. Count is equal to 0. We make count plus or equal to 1. Q dot append new row, new col. Let's continue here, right? Because we found it, right? We don't need to keep appending. Okay. It's inbound. We found it. We've added our count. So I'm thinking we're going to have so many different ways to get there, right? Because technically is a new way to get there every time we create a new row, new col. Could that be a new way, right? Because technically what I'm doing here is we are checking if it gets here and then appending it, right? Which because we have to think about the choices, right? Like, let's just see what it gets, right? Let's see what it gets. I can't really visualize that in my head. It's definitely a little tough. We can return our count. Object is not callable. We've got the and here. I guess we don't really have a grid, technically, right? Yes, if new row, new call. Shit, do we have to make the grid then? Do we have to make the grid? I don't think we have to make the grid. Make the grid for row in rows, call in calls. Grid row call is equal to 0. Let's print string comprehension. I always find this tough, but let's print out grid. We get an output of 2. I'm thinking every time we add a new grid, we continue. Zero. Yeah, I'm not sure. Visited is unnecessary. You shouldn't. Okay. Okay, so we don't need a visited. Okay, we can append our queue. Or as we come here and we do, well, if row is equal to rows minus 1 and call is equal to calls minus 1, then we want to count and we want to continue. We want to break out of this, right? We continue. We append with our queue. We can get rid of this grid, get rid of that print. We just messed up. We didn't need the visited, or else it would have worked. Because we need all paths. Okay, memory limit exceeded. This is where we need to add DP now, right? So how can we add DP? Dictionary. How did I do this using DP? Zero, zero. We have 1, right? And we go while Q. Roll call. Okay. We get rid of this. And we loop through. Okay, we apply a new row, new call. We check if it's in bounds. Alright. Then we do, okay, well, if new row, new call, not in DP, we append to the key. Oh, it's DP, new row, new call is equal to dp.get, new row, new call. If it's not there, then it's 0 plus dp row call. Right, then we would return dp.get and -1, and we can do rows -1, calls -1, or if it's not there, then it's 0. It's a good problem. I think we're gonna leave it at that. We'll do one more problem. Why not? Let's take a look at this one. This time to buy and sell stock. Given array prices. The price is I is the price of a given stock on the ith day, and an integer fee representing a transaction fee. Pay as many transactions as you like, but you need to pay the transaction fee for each transaction. He can make you run away. How many did this guy do? Wow, he did a lot. He still does it. Nice, man. Take a look at his badges, man. He's got 365 days, 500 day badge. Jeez, man. It's crazy. Hazard prices. Profit you can achieve. Trying to think, man, what's the best way to do this? My intuition here is telling me we're just gonna have to keep track of the state, right? If we somehow bought it or we somehow sold it. So maybe. So obviously this is a DP problem, right? We're gonna have this, right? We'll leave that for now. Okay, let's do dev backtrack, right? Um. So somehow we're gonna have to keep track of our price, right? That's one thing we're gonna need. We're gonna need to keep track of our max price outside here, right? Okay. So we're gonna need our I. right, when we're looping through. So let's do, well, our base case would be, okay, well, if I is greater than or equal to the length of prices, right, then we can just return, right? Okay. Otherwise, I feel like we're gonna need some sort of flag here, right? Let's do our like flag. Let's do a backtrack. We have an I, we have a price, right? Our I, sorry, is 0. Our price is currently 0. And our flag is false, right? So if so I think we have 3 states, right? We can either buy, sell, or skip, right? So if we were to do buy, right, then we would do price equals to price is I. Okay, and then we do backtrack. I plus 1. Prices. Price. And then our flag is now true, right? Let's sell, right? Our buy would be, okay, well, if flag is equal to false, we can do this. We can buy, right? If our flag is equal to true, then we can sell, right? To sell, it would be, well, price is equal to true, and we would sell. And it would be, well, price minus prices I minus price and then minus our fee, right? Otherwise we can skip as well, right? We have our skip, which would be, we would just call our backtrack function, increase our I, keep our price, and price, and our flag would just stay the same, right? Let's do, we need to call backtrack here. Backtrack, I minus 1, sorry, I plus 1, price, make our flag false now, right? Maybe we should have our skip first so we can avoid all this bullshit, right? Skip here. Okay. Non-local max price, right? Here we can check the max. We can do, well, the let's do max price is equal to the max of max price. We would return our max price. I'll put 14. I'll put 13. What do you think about this brute force solution? Good ideas in your code. Thank you. Thank you. I do have good ideas in my code. Okay, we have our I. Right, I guess we can change this to profit. That's probably a better name for it. Right, we have our flag, and then we have our buy price. Okay. Turn our profit. Get rid of this. Zero. We did do these states okay. I'll give him that. I'll give us that, right? So we have our skip option, right? Which would be, well, max underscore profit is equal to backtrack I plus 1 holding, sorry, plus 1 profit flag buy price, right? Then we can do option 2, which is buy, right? So if not flag, then our max underscore profit is equal to the max of max underscore profit backtrack I plus 1 profit true price is I. Okay, so that was our buy price, right? That was us buying. Sell, right? Then we have the else here, and we would go, okay, sell underscore profit is equal to price is I minus buy underscore price minus fee. Then we would do max underscore profit is equal to the max of max underscore profit backtrack I plus 1 profit plus sell underscore profit. Then we want false and 0. And we would return our max underscore profit. And we backtrack 0, 0, false 0. We can return here. So now we have our DP. So instead here we would return 0. Then we have our 3 states here. Holding in DP, we would return DP I holding. Alright, that's a good way to do it, a good way for the key. We have our skip. But really, I guess now we only need our I and our flag. I plus 1 flag. Why if not flag? We have our buy is equal to DFS I plus 1 true plus, sorry, minus prices I DP I flag is equal to max skip buy. Sorry, this is meant to be skip. Sell is equal to backtrack I plus 1 false. This is meant to be backtrack. False plus prices I minus fee. Then we have a DP holding here. Okay. DPI holding is equal to the max of skip and sell. Turn 0 false. Oops. I'm the only girl in the world. Sorry, if I holding, I flag, not holding, flag. Flag, 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 flag. We have a holding here, we want a flag. Another holding here, we want a flag. Sometimes the DPs are easy to think about, but some of the DPs, I feel like for this one, is tough to think about. Like, we had the right conceptual idea of thinking about the problem, splitting it up to 3 cases, a skip, buy, and a sell. But, I don't know. That's right. It's been a long day, so I'm going to leave it there. I appreciate you guys watching, and I will see you guys tomorrow.